All right, hello everybody. In this particular video, we're going to be talking about the unit circle, which is something we've been talking about for a little bit of time now, and we've kind of began to fill in our table or our unit circle with points on the graph and kind of working our way around. And we just started filling in our table and doing those sorts of things. So I just kind of wanted to give a general overview of everything that we've done so far and extend on the idea by showing you inverse trig functions. Yes, there's a whole set of other trig functions called cosecant, secant, and cotangent. But let's first talk about our general idea of the unit circle and what these points mean. Now, like I told you guys, we've been filling this in for a little while now, but understand, like I typed in the unit circle into Google, and look at all these images that show up. All right, this is what we kind of been working with. We've been kind of filling in our own so far. But the unit circle is a very popular idea because it brings in the idea, it's the kind of beginning steps of actually graphing a trig function, which is what we're going to be doing here in the near future. And so it's a good idea to kind of get an idea of how these numbers come about. Now, I've told you a couple times the reason why we start out with 30, 60, 45 and kind of work our way around is because that bears down to the idea of a 30, 60, 90 triangle, okay? So if I take this right here and I look at this, I'm taking this triangle right here, which is a 30, 60, 90 triangle. I'm dropping a straight line down, and if I draw a triangle here, I'm trying to draw as best I can, we notice that it creates this triangle right here, okay? Now, so this is a 30 degrees. We know it's 30 degrees there, okay? And if you need to refresh your memory about 30, 60, 90 triangles, there's the previous video, Standard 5.1, that talks about the 30, 60, 90 triangles if you want a refresher. But we know that the hypotenuse is, or the side opposite the 30 degrees, is half the hypotenuse. So, based on that ratio, we know that this is 1/2 because opposite the side opposite 30 degrees, or the smallest side, is half of the hypotenuse. And then the longer side, or in the context of non-hypotenuse, but the side opposite the 60 degrees is going to be x square root 3, or in this case 1/2 times square root 3, which simplifies to square root 3 over 2. Okay, so this is how I'm getting these measurements. Notice how on the x-axis I'm going square root 3 over 2, which is why my x-coordinate is square root 3 over 2, and I went up 1/2, which is why my y-coordinate is 1/2, okay? So you have to understand that we're dealing with a whole coordinate plane here. Like the same as if I were to draw this line across here, it would be halfway in the y-axis. Notice that we call this a unit circle because it is a circle with a radius 1. So every single hypotenuse in this entire picture is 1, which is how we get these particular points. And you can test the idea on this next one, say for example 45, 90 triangle. You know that both sides are exactly the same. They both equal the same length, and that is why the coordinate is square root 2 over 2 comma square root 2 over 2. So that kind of explains this idea of the unit circle and how we're coming up with these points, okay? Now, for the context of this video and for looking forward, instead of using x and y as coordinates, I'm going to label them a and b. Sometimes when we have the x, it can be kind of a little confusing about what I'm asking, so we're just going to call a the x coordinate and b the y coordinate. So when I show all my work, you're going to kind of see a's and b's. That's what I'm referring to, that a is the x coordinate and y is the b coordinate, okay? So now that we have a kind of a general idea, actually I'm going to keep that, I'll keep that language there for you. Okay, so we're going to use this to find the exact value of trig functions. Normally when you type in sine 30, you're going to get some crazy decimal in there. But in this case, well, not with sine 30, but in some of these ideas, you're going to find that you get a crazy decimal that is rounded. We are finding exact values, okay? So, for example, if I were to look at the trig functions in the unit circle, when I type in sine of an angle, I'm finding the b, which is labeled the y-coordinate, b. The cosine theta, the cosine of the angle is going to be a, or the x-coordinate. And this is kind of a new one for us, but the tangent of the angle is b over a. So whatever, it's going to be kind of like the y-coordinate over the x-coordinate. Okay. So with that said, we are going to kind of begin our look at the kind of operations here and to look at how this all comes into play, all right? And I'll talk about inverse trig functions here in just a second. So our first thing is we got sine 30, okay? So I find the 30 degrees, which is labeled nicely. I also have a unit circle that has the radian measurements as well, just in case we will get into those, but noticing that they are the same as saying degree measure. So I'm saying sine 30. Well, I know that the sine of the angle equals the y-coordinate. So B, what is sine 30? This is 30 degrees. What is the y-coordinate, or B in this case? Well, that one would equal 1/2. And that's it, people. There's no real math to it. We're using our unit circle. We're using something that we created to find our answer. So there's real no trick to it. All right, so now we have cosine of 210. Well, cosine of an angle is the A, or the first coordinate, the x-coordinate. So if I make my way to find 210 degrees, there's 210 degrees. I'm finding the cosine value at 210, which is going to be negative square root 3 over 2. I know this because of the fact that, and I could even find this, I could drop this line over, and then I could find the value. This is a 30, 60, 90 triangle. I know it's going to be half the hypotenuse in this case, and I want to find the y value, so it would be the square root of 3 over 2. Now also notice, this is an important point here, is that when I switch my coordinates, all I'm doing is I'm abiding by the quadrants here. So like quadrant 1, 2, 3, and 4. I know that my x values are going to be, and y values are going to be positive in this quadrant. I know the x value is going to be negative in this quadrant, but the y's are going to be positive. These are both going to be negative in this quadrant, and then my x coordinate is going to be positive, but my y is going to be negative. So you'll notice that the pattern just keeps going around and around. We're just switching the signs based on the quadrant in which it lies. And so we have tangent 120. Now we haven't dealt with tangent too much, but we're going to go tangent 120 is the B. So where's 120 at? 120 is right here. So it's B, which is square root 3 over 2. Divided by, now I could write this as a giant fraction, but I'm just kind of using our tools that we know about fractions and writing it a little bit differently so it's easier to understand. So B divided by A. What is A at 120, which is negative 1/2? Okay, I'm not even going to put that parentheses there. I know I'm going past signs here. All right, so now, in order to get the right idea here, we need to multiply by the reciprocal, okay? And I'm kind of jumbling my work here, and I apologize for that, but I'll come back to it. So now we have square root 3 over 2 times the reciprocal, which would be negative 2 over 1, which would equal negative 2 square root 3 over 2. So I multiplied across, I multiplied by the reciprocal, I got negative 2 square root 3 over 2, and then what you're going to do is simplify, so we end up with negative square root 3 as our answer. Okay, so that's what I'm going to put right here. So the value of tangent 120 degrees is equal to negative square root 3. And trust me, when you type that in your calculator, if I were to take tangent 120 degrees, I would get the same answer as if I were to say negative square root 3 in my calculator, and I both get negative 1.732058808. But the idea that this is the exact answer here, the exact answer that we want, okay? Negative square root 3, okay? Now, with that said, oh, don't want to erase that. Okay, I always test to see whether I'm erasing the picture. And so, I'm going to leave that there. So we have negative square root 3 right there. Okay. Now we're going to deal with inverse functions. Now all that is just a new set of kind of language we're going to be using. This is going to come into play when we graph trigonomic functions. So if sine, the inverse of sine is called the cosecant, abbreviated CSC theta. The cosine, the inverse of cosine, is called the secant, which is abbreviated SEC. Yes, not the Southeastern Conference, college fans. And then we have the tangent, which is its inverse is called the cotangent, which is a lot nicer than these kind of two. So all that does is just inverse the function. So like, for example, if the inverse of sine is 1 over b, The inverse of the cosine is 1 over a, and the inverse of tangent is flipping this fraction, which is a over b. Now understand that this is different from the arc sine. This does not mean -1, okay? So do not confuse that with this particular case. This is the inverse of the function sine, okay? When we use arc sine, that deals with a kind of a different context in a way. All right, so what we have here is the cosecant, so CSC. So we want to find the, draw a little line there. I want to find the inverse of cosine at 150. What is 150? 150 is right here. The cosine is this function right here, so all I want to do is find the inverse of that. Well, if I do that, I'm just going to kind of flip it here, and I'll kind of show you what I mean by that. Is if we have 1 divided by square root negative square root 3 over 2, right? And we multiply that. I'm kind of taking a very long way here, and I'll kind of show you how to quickly do this. And we take the inverse of that, so that would be -2 square root 3, okay? Now you'll notice that I took a very long route on that, okay? All we have to do is just flip the result at 150. So what's the cosine value at 150? Well, if I look at that, cosine 150 is a, cosine 150 is negative square root 3 over 2, so the cosecant of that is just -2 over square root 3. Inverse function, okay? Secant, oh, I made a bad mistake. No. All right, I apologize. This happens here. So the cosecant refers to the sine function, which the sine function is b, not a. I apologize. And so our value here is 2. Okay, so the inverse of the sine function at 150 is equal to 2. All right, and we'll talk about that. Do not worry. And is that possible? We'll kind of look at that as well. Because can it equal 2? We'll see. Okay, I want us to talk about this and think about this on Monday. What we have here is the secant of 300. Okay, so the secant refers to the cosine, which refers to a. 300 is again 2. 1 over 2, or the inverse of 1 over 2 is 2. Again, something we are going to talk about on Monday. Because certainly, can this value be 2? Maybe it can. You have to find out. You are going to look at those. We're going to experiment with that here on Monday. So now we have cotangent of 30 degrees. Okay, so cotangent of 30 degrees is a over b. So we have 30 degrees. Cotangent is a, which is square root 3 over 2. Ooh, bad 2. Divided by square root 3 over 2, divided by 1/2. Okay, so what we're going to do is we're going to flip that, and so we get, let's see, square root 3 over 2 times 2 over 1, which equals 2 square root 3 over 2, which our end result is square root 3. Okay, so a couple things I want us to talk about. I kind of worked a lot of stuff here in this video, so it's kind of extensive, but I want us to talk about this and look at these two things. Okay, we do have the inverse, but does this work? And you kind of think about it a little bit. It goes by the functions here, but does it work? All right, have a fabulous weekend, and I'll see you all on Monday.